Afternoon from Base N. My name is Judith and I am your host today. Today our topic for our webinar is situational awareness, digital twins for networks, and everything. And our journey today will be guided by our wonderful CEO, Mr. Pasi Hurri. Warmly welcome, Pasi.
All right, thank you very much, Judith, and I'm happy to present you today some slides from our webinar, and it will be quite fast-paced, and we hope that you pose questions at any point, because we'd like to keep this session as interactive as possible. So, situational awareness, that is in the core of what Base N does, and a little bit of that actually is related to my history. So I'm the founder and CEO of Base N, and I've been running Base N for 22 years now. And before Base N, I was presiding the engineering effort of KPN Quest, where we were building about 40,000 kilometers of fiber across Europe, and that was a very interesting exercise when we were building the world's largest network at that time, and we were carrying about 60% of internet traffic globally. And I'm also a general class amateur radio operator. That's my call sign there, Oscar Hotel 2 Tango Whiskey India. And there you can see in the picture that I aim for high places nowadays. So that is my telecom mast in the presentation. And I'm also air combat controller in the reserve in the Finnish Air Force. And the idea for Base N actually came from those times more than 30 years ago, because the Finnish defense system, before the European Union and before we were integrated into NATO and other systems, we built quite a lot of those systems alone in Finland. And there were quite some innovations in collecting radar data and sensor data and presenting it in real time to decision makers. And that actually inspired me to create something similar, first to telecommunications and then later to almost everything else. And a little bit about Base N. So we utilize our own military-inspired platform to situational awareness and uninterrupted network management and incident response and troubleshooting. So practically, we create digital twins of everything that we touch. So that has been our way of doing things. So we collect telemetry as much as possible, so we understand how the physical world and how the physical assets are operating, whether they are network assets or whether they are other industrial assets of considerable value. And as of today, we are processing about 70 gigabits per second telemetry and real-time data from customers. And I mentioned, and Judith also mentioned that the headline of this webinar is about digital twins. And there are many definitions for digital twins. And we actually define digital twin the same way that the US NASA did in the 1960s when the Apollo program was launched, because in the Apollo program, money was no object. So the US had to go to the moon before Soviet Union. So they created first physical twins for the Apollo spaceship. And after that, they realized that they cannot create many of them because it was even then prohibitively expensive. And therefore, they started getting telemetry from every asset that was connected to the spaceship and the booster rockets and so on. So there was a small radio transmitter in almost all the critical components, which was sending the telemetry data into NASA's platform, so they knew exactly how things were operating at any point. And it proved invaluable, especially in the Apollo 13, when they had a catastrophic failure in one phase of the mission. So having that situational awareness and being capable of then combining assets that were not earlier thought to be used together. So the crew in Earth were able to assemble air purifying systems and other life support systems to keep the crew safe. So that was, I think, one of the nicest implementations of early digital twins. And we think that situational awareness is about digital twins of customer devices and millions of them. So even though you are a telecom operator who has, let's say, 500 million customers, it is possible to collect telemetry from all of those. So something like 20 years ago, it was hard, but we made it possible. So you can know exactly how well your customer devices are operating. And you can model the complete customer service environments also. You can model the capacity requirements. You can create forecasts based on the data. And at the end, you can actually model the individual customers and their usage patterns. And of course, the radio access network RAN and the core network, they can be or should be modeled and telemetried carefully, but it should always be rotating around the customer digital twin. And that's sometimes forgotten by very technical engineers, that the network exists for the customers and not for the network, even though it's fancy to have 100 gigabit links between sites and be happy about them. And nowadays, when you have that kind of a digital master database and a real-time repository of the network, you can utilize then modern machine learning techniques and find those best practices and risks even before they materialize. And as of today, if we think of almost anything that is being produced, many things are already software defined, even though we don't necessarily think so. So if I'm talking about this coffee mug here, there is a digital twin somewhere of this coffee mug, because this is most likely machine created. This is not made by any human. So there is a CAD and CAM model. So CAD model in AutoCAD or some PTC software. And then there is a computer-aided manufacturing file that is put into the kind of a printing machine, which kind of spews out thousands and thousands of these cups. But it almost ends there. And we see that actually it shouldn't end there. So we should have telemetry from this mug even when I'm the end customer of it, as of today, as I'm drinking fairly bad tasting coffee from it. And the paradigm has changed in about 20 years now. So it's not this is a very rapid thing, and we are gradually moving away from the so-called fire and forget model, which I'm going to talk about a little bit more. And as of now, Bayes-N sees that there are two types of digital twins. So the first one, which is the more common one, is the telemetry-based and schema-based, easily visualizable situational awareness entity for existing physical assets. So if you have routers, switches, base stations and repeaters and whatever you have in the network. You have a scheme that where things are, and whenever you put something new into the network, you first create a scheme and then kind of have the as planned plan, and then you have as built documentation, and everything is recorded nicely. But the key thing is that nowadays you can actually get telemetry like 10 times more than before, and current systems like base and platform can actually take in all the data, so you don't you are not blind at any point. And you can manage complex environments with this kind of in a way reactive solution, and you can show the digital twin all the way to the end customers with all kinds of portals and mobile applications. Sometimes you can even have VR glasses if you have a digital twin of a drone, for instance. And the digital twin of a network is usually, it comprises of a geographical map. It can have a network topology diagram on several layers depending on the technologies used in the network. It can have time series charts, it can have pie charts, it can have dashboards, and it can have forecasts and projections. But unlike in traditional network management, these are all dynamic. These can be added and removed and refined based on the customer needs and based on the network requirements and customer product requirements. And everything should be on the same data plane, meaning that you can combine any data between different network locations and aspects. And then the number 2 digital twin, which is the current and future digital twin, is actually the digital master of a thing before the thing is created. So it is the complete digital representations of a service or product, and then these entities can be combined with each other to create twins of twins for customers. And then physical assets are kind of coming and going whenever required. And you could think of a mobile subscription as one of these things, because it is not tied to any hardware at the operator or at the end customer. The subscription is recording information from the customer patterns, and then the necessary hardware is implemented in order for that to be provisioned. But in many times the thinking doesn't go this way, because it is so easy to kind of fall back to the system that, I build network and then I create some, I buy hardware and then just push it to the end users. But we should think the end users as the primary entities, and when you are reaching your, let's say, digital goals, you will have a digital twin of your customer. So you can even forecast that what your customer is about to order from you and what kind of services, other new services you could push to them individually and mass customize your products. And in the type 2 digital twin, as we call it, the idea is that you manage the entire life cycle of your service or product, so that you don't fire and forget your product to your customer and then just put some marketing and wait that your customer comes back and buys more. The idea is that you utilize the telemetry that you collect and create trust between you and the customer, so that the customer benefits from your current and future services all the time. There are companies who are doing this very efficiently now, like Apple and Amazon, but we think that this capability should be at all customers. And to poke a little bit on telecoms, I have a saying that telecoms have not invented anything in 100 years. Well, that's not exactly true, but the thing is that many telecoms have millions of end customers, but they often limit the services and don't even think that how could this customer base be utilized, even when you have such an intimate connection to them, like providing mobile subscriptions and fiber subscriptions and things like that. But it's very few telcos that have actually been able to utilize this kind of a marketing plane towards customers so that they would have been a trusted partner in anything else than the telecom service. And when you have this kind of a digital twin of the end customer, you have much faster research and development cycles, and you can have constant innovation and more granular innovation towards your different customer groups, and you can maintain the wisdom that you collect so that you don't forget it when you launch your new product, because the life cycle is recorded. And I would say that today many networks have some digital twin capabilities. So we have seen in Baysen hundreds of network management environments and network operating centers, and I would say that something like 50% of the capable telemetry is being collected and analyzed. But many times the network management solutions are very complex, difficult to maintain, and then they are not easily used by the engineers, and the data is not fed all the way to the end customers. And this makes the network difficult to manage. And whenever you introduce new services or new hardware like 5G or 6G and things like that, you have difficulties in ensuring that there is a smooth transition and your customers are complaining. But this actually, it is mostly because of the thinking that network management is this kind of a monolithic necessary evil. So we think that from a necessary evil, the network management function should revolve around the customers. So that we think that, that what does the end customer benefit that I'm implementing this kind of telemetry and digital twins from all of my end customers. And then you start realizing that actually you need to get the data all the way to your end customers to show and prove that your service level is at the level that you promise, and that your speeds are as you promise. And then you suddenly have a platform where you can see new opportunities that could be offered to your end customers. And I would say in general, in digital twins, most companies are in this kind of a pre-stage one, that they are communicating and selling products to their customers in one way, in this fire and forget model. So I have assets, and then I have a factory, and in that factory I build stuff, and then I sell it to customers and then restart. And it's up to the customer to come back to me, and this is actually not a very new or actually not too old model. So it's only about 150 years that we have been doing it this way. And I would actually blame Henry Ford a little bit, because he devised these assembly lines and conveyor belts that where you just created cars as fast as possible and as many as possible and pushed them as ready products to customers. But before that, business used to be much more bidirectional, and companies were interviewing and analyzing the customer needs much better. Now this one directional mode, I believe that with the emergence of climate change and other resource scarcity, we actually need to go back to this kind of two-way understanding that we don't create so much waste whenever we create things, and we analyze the full life cycle of the product and make sure that the raw materials are properly recycled. And I believe that the vendors and need to be responsible for that. And at the end, it is better for business, and it's also better for the planet that if we are able to create this kind of a new business environment where we customers are paying as they go, and they don't kind of buy your asset just to be underutilized. Some companies like Uber or Airbnb have been able to kind of create fairly new models based on this, but I think those are just scratches of the future when we think how easily things can be connected today and how easily you can collect and analyze data. Of course, you need to be cautious of privacy and security, and everything should be revolving around customer trust and the customer's data, so that you don't sell it to someone else unless you have a permission from the customer. So there are a lot of aspects to be taken care of, but as of our kind of cloud provider, I would say that we have an obligation to create sustainable future when we have this kind of cloud capabilities and telecommunications capabilities today. And telecom operators are in pole position to support large enterprises and smaller enterprises to get to this new sustainable model. And if you think your current assets, that how well, what is your situational awareness of your home appliances? So did you just fire and forget when you bought your vacuum cleaner at home? Do you know what's the condition of it? Do you know when was the filter changed? Is it actually pushing dust everywhere because the filter is not changed? So how old is it? Is it electrically safe? So if your children are pouring water on it, do they get the electric shock from it or anything like this? Chances are that you have no idea. And this is the case for, I would say, 90% of people right now. But it wouldn't have to be this way if the appliance manufacturer would actually take a bit more responsibility of the life cycle. And it is just a change in thinking, I would say. And we have also seen, especially in the US, we can see that large hotels and apartment buildings, that they have hundreds and hundreds of air conditioning machines. Sorry. And those are serviced individually, and no one really knows how efficient they are and when they were serviced last time, and how much energy they are consuming. So this is all forgotten because of the conveyor belt model that these machines have been built. They are installed and they are operated until they fail. But we need to get rid of this in order to be more efficient and in order to have digital growth instead of just junk growth in most markets. And if we talk about telecom operators, mostly the most common use cases for digital twins are network planning and optimization, because when you have a network from 2G to 5G, you actually have quite a lot of technologies overlaying each other, and it's quite a task to do capacity planning if you have a kind of black holes in your network you don't know about. So it's critical to have this kind of a scheme in the beginning that that like our customers have, that whatever you put into your network, you first need to ensure that you get telemetry and the health data coming from those elements. And when you have telemetry, your fault management and troubleshooting becomes much easier, and you can have fairly easily root cause analysis across all services in the network. You can have a predictive maintenance. You can predict the age of your fiber connections, for instance, and you can isolate faults after catastrophic events like a weather phenomena and things like that. And you can simulate these phenomenons, which is becoming more and more important when we are seeing these storms and snowfalls, kind of surprisingly more. And as said, when all the people who operate and use the network, when they have the same view of the network and they know what they talk about, the developing and creating new services becomes much easier. So the digital twin should be the central object and an idea that people are familiar with. And many times it's funny that many of our customers have names for our platform, how they are showing it internally and externally. And many times those customers are calling the network base N in a way that that it's let's look on base N. So it has become a kind of a household name in many ways, because we have been able to standardize how things are supposed to look like. It is very difficult to describe how a photon looks like in a fiber, but when you have a nice visualization and the same visualization for everyone, it becomes much easier. And if we think of a telecom provider and there is a bank as a customer, banks are nice customers for telecom operators because they usually buy a lot of high capacity bandwidth and they want low latency, so they're readily paying quite a lot for the services, as opposed to, for instance, individual consumers. So there are software-defined wide area networks quite a lot. And there are a lot of remote workers nowadays. There are ATMs, there are credit card terminals. So you can virtualize a lot of things that previously had to be implemented as separate services, and telecom operators or the banks and financial institutions often want also on-premise and, let's say, in-country installations. So they are more prone to come to the local telecom operator instead of going to Microsoft or Amazon in all of their services. Of course, many of the customer-facing projects are still going to the larger cloud providers. But if I were running a telecom operator in almost any country, I would take very good care of my VIP customers, like the banks and financial institutions, because they are ingrained many times with the society because of these identification and personal ID solutions. So the service level becomes more and more important, even though things are delivered over the public internet. So for banks, situational awareness of the services, they are ready to pay for it, and they also benefit a lot when they can predict any kind of outages and can plan the growth of the customers. And also, if as a telecom operator, you could share the experience with the bank on creating a digital twin of the end customer, because the bank account is a kind of a digital twin of your financial state. It is actually that there is no physical money anywhere when you have your bank account. So that's a good example of a digital twin. So you could learn from each other as a telecom provider. So how could you combine some of the services, like in the Nordics, banks have combined these authentication and personal identity verification services. That's just the one way of doing things. But whenever you introduce these services to your end customers, you need to make sure that they are at the mission critical level, because if your customers are relying on your subscription on authenticating themselves to, let's say, for voting and things like that, they expect that it works 24/7. So you need to have a back office systems that make sure that you can have that resiliency. And as said before, the most important digital twin is the digital twin of a customer. So we urge you to think with the eyes of and brain of millions of your end customers. So that's how you are able to think of new services that you could introduce, and they might be fairly untraditional. So even though business schools were telling you like 30 years that concentrate on where you are best, the fast pace of digital technologies has now caused it to be outdated. So you actually need to understand that what are you best at today, because tomorrow that might be something different, and the data and the digital twins will tell you that what those might be, where you are best at, and sometimes you need to try out different services and different solutions on top of your infrastructure. And to conclude, I could tell a couple of success stories from as we have created digital twins for our customers. So one of my favorite customers is Norse Power, and they actually resurrected a 100-year-old innovation. So 100 years ago, there was a company trying to create this kind of a rotor sail on steam ships that would actually generate some thrust based on the so-called Magnus effect. That if you have a rotating cylinder in a ship that has a certain speed and a rotational speed and a certain angle towards the wind, you can generate up to 15% thrust with it, just like a sail in a sail ship. And the pilot was successful in 1920s. But the problem was that the solution required 4 people to manage it all the time, so to adjust and make sure that it's always in the right angle. But now, when there is a digital twin of it, each of those rotor sails at Norse Power have about 120 sensors that are continuously sending data to base N, and then Norse Power can adjust and analyze that, that based on the wind conditions, that which kind of programming is best for any situation. So each of their services, each of their rotor sails have a little bit different programming based on the actual conditions that they are used in. And these are some of the let's say this gives some hope that we are utilizing all of the old knowledge from 1920s that we forgot because we got so excited about the conveyor belt and the wasteful production. Also, the other let's say visionary customer is Assa Abloy, and they created digital twins of construction sites and people moving on those construction sites and all the safety equipment. So making sure that people are safe at all times at construction sites. So they were able to, with fairly small amount of telemetry data, to ensure that people have their hard hats on when they are in dangerous areas, and that they have their reinforced boots, and also and that they don't forget any of the expensive tools to wrong places. And this first and foremost, this solution enabled better safety for construction sites, and actually that's why it was so well approved by fairly stiff construction industry. So no one else had done anything like this before. So this was a completely new service, which is now being sold globally by Assa Abloy, and that's something that we always want to foster and see that companies could create totally new combined services and create new business around it. And of course, one of our favorite telecom operators, Deutsche Telekom. Our history with Deutsche Telekom is quite long and complex. So we have several countries where our situational awareness system is used as a primary solution, and in some countries it is used only for customer portals, and sometimes it's only a NOC system. But the nice thing is it's always growing, and we are getting more and more ideas on how to implement it faster. And now, luckily, we have been able to combine some of the features between countries, because we still think that as I was building 40,000 kilometers of fiber 23 years ago, we could still have unified telecom services across the planet, so they wouldn't have to be so different and complex as they are. And with our kind of platform, which scales to something like that, that would be possible. And those were my quick slides for today. And now I hope that Judith, you have a lot of questions for me.
There certainly, you covered a lot, Pasi, thank you for that, but there certainly are some questions, some from myself, and actually you covered the question, what is your favorite digital twin solution? But overall, the current worldly situation with outages everywhere is quite concerning. So how does digital twins better secure us from outages?
Well, first of all, when we see these, let's say, bank and let's say CrowdStrike type of outages, you can't avoid them completely, because sometimes just the unimaginable happens. But with when you have situational awareness through digital twins, you can much faster isolate and plan for auxiliary services and introduce those. And first and foremost, you can, if we think of the communication of banks and let's say airlines in the recent large outages, the communication has been fairly bad and slow, and that's because there is no good situational awareness. So I believe that, for instance, in the bank circles, it takes too long to understand that what is impacted and how many customers are impacted right now, and how what to do in order to start mitigating. So there is this kind of initial chaos, and with the digital twins, this can be minimized.
That are some good hints for banks and others suffering or of this kind of matters right now. Then, how do you see what is the added value for long-term customers?
Well, sometimes it's quite hard to think about because we are so used to this fire and forget model. But when you have long-term customers and when your brand is recognized enough, you can actually deploy completely different services to your customers. So you can multiply. It's much easier to sell to the existing customer something new than gaining a new customer. And there are historical examples like 3M is a good example that Minnesota mining and manufacturing company at the end now some of their biggest product lines are adhesives and the post-it notes, which is very far from mining and manufacturing. And but it all started even with them that they had some similar customers. So they had a customer base where to try on these new services, and they had before post-its they had a lot of different other services that they tried out and realized that, well, this might not work, but post-it notes and the adhesive worked. And many of you probably don't know, but 3M is the market leader in the CPU heating pads in almost all of the computers that you are using and the phones. They have these heat sink pads that are transporting heat outside the processors, and 3M is the market leader there.
Then there's a question. You were talking about the two types of digital twins, and there's a question, is it wiser for an operator to be bold and start from the type 2 digital twin, or start with type 1 and gradually move to type 2? And you could also still remind what were the types.
Well, for current telecom operators, because of some of the legacy hardware that they have, which is well used and spent, they will have to start from type 1s because you can't go and replace your entire network. I don't think that those KPN Quest times come back very soon, where you had, because I had €1 billion budget to build completely new network. But as we all know, that there was a telecom bubble, so this wasn't the investors actually were quite disappointed that there was not so much growth in usage. It's nice to see that those assets are now in very good use, but it took more than 20 years before all the fibers were in use. So we see that most of the telecoms have still a lot of kind of black areas in their networks that they don't know how things are operating, and that is why we are still seeing call drops and outages quite a lot. So starting from the type 1, which is the fully telemetry and schema-based digital twin, that should be at the beginning.
Thank you, Pasi. Also, a little bit about the practical side. So, how will the digital twin integrate with existing network management systems and data sources, and how slow or fast processes these actually are?
Well, that all depends on, of course, on the hardware in question and the service environments in question. Most of the newer network management systems are very open, and you can easily integrate to them. When you go to older infrastructure where you have to implement protocol converters and things like that, there might be some difficulties. But with the emergence of Open Radio Network Alliance, ORAN, and others, we are seeing very welcome openness. So that these initiatives have really helped the digital twins to be more possible today and increasingly more possible than before.
Thank you. Then How about the security and privacy of sensitive networks? How can the data be protected in the digital twin?
Well, when creating a full-scale digital twin, you must ensure that all the data is encrypted and also authenticated. So whatever data you take in should have an asymmetric encryption in place. Luckily, all these protocols are fairly mature nowadays compared to only 5 or 10 years ago. But there is one aspect actually that has to be taken into account now, and that is quantum computing and quantum technologies, because it might be only a few years that we are reaching a situation where most legacy encryption protocols and schemes are outdated. And because of emergence in quantum technologies, and there are already quantum safe protocols available. So if you are a telecom operator or any data centric provider, you should be looking into quantum safe protocols right now, because otherwise you might have a kind of a year 2000 problem in steroids very soon.
That sounds something that we really should prepare for. I would say too.
I never thought that I would actually be discussing about quantum technologies. I studied quantum mechanics a very long time ago in the university, and in Richard Feynman's words, anyone who claims to understand quantum technology doesn't understand it, because it's ununderstandable in a way and how it works. But we have so many practical applications already that in processors and quantum tunneling and things like that. So we need to take it seriously that encryption and let's say the fabric of reality as we know it, it can change quite rapidly.
That's very insightful as well. And also, how about what kind of data is needed to create realistic and accurate digital twin?
So I would say that the most important is let's say that the scheme is thought out and the kind of a speed of the data that you are getting in. So you should ensure that it's always real time. And of course, we need to remember that sometimes if you have let's say a Coca-Cola bottle and you want to have a rudimentary digital twin of it, it might be that it's you get data only 5 times during its life cycle, like a few bytes all the way when it's manufactured and then when it's recycled. So that's, in some cases that might be enough. But in some other cases, if you create a digital twin for a surveillance drone, of course, you must have several megabits per second and even gigabits per second feed all the time to understand all the vibrations and wind variations and things like that in order to control it efficiently. So the answer is that it depends on what you are about to do.
There's also one question. This could be the one that finalizes this webinar today. And since we have so much data from everywhere, and of course in some of the products or services, if we think that as much data as possible gathered helps to create better new services. So how about storing that data, and what kind of problems you see with all this data that we have going around and stored?
Well, previously it was a big problem to be able to store even some terabits of data. But now with the emergence of new storage chips and SSD technologies, we can have data online instead of having it on magnetic tapes and let's say the cassettes or discs like before. But one of the issues is that we actually don't know about the longevity of these newest memory sticks and chip-based technologies. So we need to be careful not to trust that the data can be retrieved after 30 years, for instance. Just recently, as an assignment, I had to dig data from 35 to 40 years ago, and I realized that I could read all the magnetic tapes, and I could read 5.25 floppy disks with the kind of a refurbished computer, but I could not read 3.5-inch floppy disks. So something had changed. So the older floppy disk was actually much more sustainable than the 3.5-inch, and I don't know why. And it might have been a humidity that those were stored in, but I think that we should think to keep most of the data accessible online, even though it consumes a little bit of energy. But we should look at also the quantum technologies on storage, because there are so many capabilities now on with the, let's say, quantum dot storage systems.
Now, as we are starting to finalize this webinar, I would like to ask you, Pasi, what is the one thing that you would like everyone to remember from today's session?
So that's very easy. So don't fire and forget your products. So take care of your customers, understand them, collect the telemetry, and maintain the trust.
Great advice, not only financially, but especially for our planet. That's something that we should always think about as well, our legacy. And that is something core in our hearts at Base N. So thank you very much today, Pasi, for this very insightful session and everyone joining us. And stay tuned for our coming webinars concerning other industries.
All right. Thank you very much, Judith.
Thank you, Pasi. Have a wonderful day.